Hi, my name is Ronnie Chowdhury and welcome back to my practical concurrent C++ 14 tutorials. Today I'm going to have a really short video. It's just about loop optimization. Let's take a simple loop. In here we iterate over a vector. If the index is 0 we add 2, otherwise we multiply by 2. A lot of loops you'll see there's some special conditions at the beginning or the end of the loop. So that's the first thing I want to address. Every time you iterate over the loop you have an if statement, which translates to a CMP in assembler. So that's an extra comparison that you're doing on every iteration. You may also need to load up a value from memory or possibly in a register to compare against. This impacts your performance. First thing to do is help the compiler by hoisting out the if statement out of the loop. We put the v0 plus equals 2 outside before the initialization and then change the for loop to use 1 to v.size as opposed to 0 to v.size. Compilers are very smart, but unfortunately they cannot read your mind. The best way to take advantage of that is to use patterns that the compiler recognizes. STL algorithms are the perfect use of patterns here. I rarely use for each loops because I normally want functions that are testable, that do not modify state whenever possible. I totally grant you that in some optimization cases this may not be possible and an in-place change may indeed be the best way, but in most cases you want to transform data from one to another. So immediately I would be using transform. Now that you have a transform function, you can parallelize it using parallel transform, as long as the individual elements of the output vector are independent. Moving on to classes, here's an unnecessary use of if. We create a struct foo, default constructor, copy constructor. In code you may see foo a equals b. Fair enough, copy constructor is called, or equals operator in this case. When was the last time you saw foo a equals a? That's such a rare occurrence, except in your code you've put an if statement every time a copy occurs. So that's impacting your performance unnecessarily when it's not used maybe 99.99% of the time. That was a very short video, but it was just to show a couple of small techniques that you can utilize to help your optimizer. The more straight line code you have, the better it is for your CPU. It can use the prefetcher to get as much data as it can, and you won't have things like cache misses and cache spills and so on. Thanks for watching, and I hope you join me for the next video.